So here I have to use both KCL and KVL, first law and second law, to calculate the current through each resistance. Suppose I first use the KCL. All of you just observe where is the junction. Junction is this point and this point. There are 2 points. Okay. Here I say total voltage is written in this branch is 6 volt. Here 10 volt. Here 8 volt. I should distribute it. Here I say 6 volt voltage. Okay. Then it is negative, it is negative, it is negative. I say it is 0 volt. I say common. Then here it is 10 volt voltage. And here it is 8 volt voltage. And here I say voltage is X. What Kirchhoff current law says? Sum of all outgoing current net should be 0. Summation I out equal to 0. Okay. I apply here. You will say X minus 6 upon 5 plus X minus 8 upon 10 plus X minus 10 upon 4. This should be equal to 0. Okay. Now you please solve yourself for the value of X. I am giving you 1 minute. If you solve it, you will get X equal to 90 by 11 volt. Okay. Now, if I ask you what is the current through 5 ohm resistance, you will say we have discussed X minus 6 upon 5. Put the value of the X, that is 90 by 11 minus 6 upon 5. Then current through 10 ohm resistance, you will say X minus 8 upon 10. Put the value of the X. Then current through the 4 ohm resistance, X minus 10 upon 4. Now you solve yourself. Okay. So after solving, I think you will get the result that I will write on the next slide. Before, and one more method I will discuss, KVL. KCL I have discussed. Now I will discuss KVL with you. Let me discuss KVL. Sum of all potential differences across or in a closed path should be 0. Suppose I label this path, like I say this is A, this is B, this is C, this is D, this is E, and this is F. Okay. Now all of you apply KVL in path A, B, C, D, A. Suppose you assume this is the, in this branch, due to this current is I1, and here the current is I2. You assume in that way. Now you solve it. Okay. So again I am telling you, in this loop I am taking current I1, in this loop I am taking clockwise current I2. Okay. Now we are applying KVL here. Suppose I start from this point, A point. Okay. Then along the direction you will say plus 6. Here you are moving along the direction of flow of current, minus 5 I1. Okay. Here you say along the direction of flow of current is I1. So you will say minus 4 I1. But I2 is opposite to direction of flow. So you will say minus I2. So ultimately it will be minus 4 I1 plus 4 I2. So you can say it is net current in this direction is I1 minus I2. And then you will say plus 2 minus, so you will say minus 10 equal to 0. Okay, you get one equation in I1 and I2. Now all of you write the KVL equation for the second loop, that is D, C, E, F and D. Suppose I start from D point. This is my D point. Along the direction plus 10. Then you see minus 4. I2 along the direction, I1 opposite direction. So I will say I2 minus I1. Okay. Minus 10 I2. Then plus 2 minus. So minus 8 equal to 0. Now we have two equations. And there are two unknown. So because there are two unknown and we have two equations, so we not require any other equation. Number of unknown equal to number of equation. Now you please solve for I1, I2. If you solve for I1, I2, in this 5 ohm current I1, 10 ohm current I2, here you will say current is I1 minus I2. Okay. So I am showing on the next slide. I think the solution is not written here. Let me write. Just please verify it because it is not written. So I1 should be equal to, okay, let me calculate, then I will write. Just a minute. So you should get this result. Okay, so verify it. Now another question. You have to use the Kirchhoff voltage law, any second law, and you have to calculate the current through each loop. So first you should try to solve it. Again I assume here that in this loop the current is flowing, that is I1, and in this loop clockwise current is flowing I2. Okay, so firstly I label it A, B, C, D, E and F. All of you write the KVL equation for path A, B, C, D, A. All of you write. Okay, so I start from this point like this. This is 20. I think in the sheet which I have given to you, this end is positive. So please make it positive. Otherwise, answer will not match from the sheet which I have given to you. Okay. So you will see it is minus 20, then minus 2I1, then minus 4, yes, I1 minus I2, then minus 10, minus 3I1 equal to 0. You get one equation. Second loop, you start from this end like this. Suppose you say you are moving here. You will say minus 5. You are starting from this point. Minus 5, minus 5 I2, then plus 10 volt, minus 4 I2 minus I1, minus 3 I2 equal to 0, equation number 2. Now you solve yourself. The value of the I1, value of the I2. It's your job. Okay. So please make one correction so that your answer will match in this battery. Okay. Then we move to the next question. Before starting the next question, so again I want to tell you, please use the sign convention yourself. Suppose this is the battery. You are moving along this direction, you will take plus. You are moving along this direction, you will take minus. In the resistance, if current is flowing like this, you are moving along this direction, you will say negative IR. You are moving along this direction, you will say plus IR. Now you please solve yourself. Pause the video and please do all the solution yourself. Check it. If any error is there, you can ask me. Again, this is also very simple question. You please try to solve yourself. Check the solution. If any doubt, you ask. Again, you pause the video and solve this question. Now, one thing is here. Here I have shown the capacitor also. And in the steady state, you know, no current will flow through this branch. I am giving you the hint. You please solve it yourself. So now I will show you the solution. Check the solution. Okay, this is good question. All of you try to solve. Pause the video. After solving, you listen it. Of course, we have done a lot in previous videos, but still I will explain you again. I observe the cross section view R1 and R2. Assume a cylindrical layer of radius x and width dx. Of course, length is same, that is L, this elemental part. Now I write the resistance of elemental part first. Okay. So what I will say, rho L. What is the length of this elemental part? Dx. And cross section area, you will say 2 pi x into L. Now I will integrate. Limit of the x will be taken from R1 to R2. Okay. Now I will use the formula I equal to EMF is E upon net R, and I will get the result. So all of you just observe it. Is it okay? Now Wheatstone bridge. Exactly we have discussed in capacitor. If there are 5 resistance, or you can say 4 resistance, P, Q, R, S, G is the galvanometer. When there is no current in the galvanometer, you will say ratio of the P by Q equal to R by S. And how we will solve? We will use the Kirchhoff equation for the solution. Let me explain you with the KCL, Kirchhoff first law, Kirchhoff current law. Okay. Suppose I say this battery of EMF E, in some books you can read voltage V, it doesn't matter. So voltage V means here the voltage is V, here the voltage is 0. Okay. At this point I say potential is X, at this point the potential is Y. Okay. Now if I write the KCL equation firstly at the junction X, what I will write? X minus 0 upon Q plus X minus Y upon G plus X minus V upon P equal to 0. G is the resistance of the galvanometer. Okay. Then I write the KCL at Y junction. What I will say? Y minus 0 upon S. Y, this should be plus, sorry, plus Y minus X upon G plus Y minus V upon R equal to 0. Now, when galvanometer does not show any deflection, it means potential difference is 0. It means voltage X equal to voltage Y. We put here, then you will automatically get P by R equal to Q by S, or P by Q equal to R by S. This is the balanced Wheatstone bridge situation for balanced bridge. So whenever the bridge is balanced, means ratio of these two arms is same, we will not count this galvanometer resistance and we will solve the question. You can use with KVL also. I think in the slide we had shown you the KVL. So you can do with the KVL also. Different loop. You take this loop, make the equation. You take this loop and make the equation. Okay. So let me come to this point again and let me show you the KVL. Firstly, I take this loop. All of you write yourself the KVL equation. Then I take second loop. All of you write the KVL equation. Then you will say no deflection, Ig is 0. Solve the equations and we get the result. Okay. Now these are some points which you are supposed to know. Just know when I will discuss the meter bridge, I will explain in detail. Weight-Stoned bridge is most sensitive if all the arms of the bridge have equal resistance. We will discuss there. And then these 3 points are simple points. Only the third one, in Weight-Stoned bridge, to avoid the inductive effect, the battery key should be pressed first, then galvanometer key, because otherwise induction effect will be there. That also I will discuss in the meter bridge. And last point, you can read. Suppose it is unbalanced bridge. No, you cannot say that you can delete the 4 and you can calculate 538, 628, 884, because this is unbalanced. Because ratio here 5 by 3, ratio here is 3 by 1. So now how you will calculate? Let me solve you if you are not able to solve. Suppose I say I connect the battery here to make the complete circuit. Okay, and let I say here the voltage is 100 volt. You can take 50 volt, you can take X volt, it depends on you. It means at this point voltage is 100 volt, at this point voltage is 0, at this junction I say voltage is X, at this junction voltage is Y. Now you apply KCL. Firstly for junction X, what you will write? X minus 0 upon 3 plus X minus Y upon 4 plus X minus 100 upon 5. This should be equal to 0. Equation number 1. Then write KCL for Y. KCL for Y. What you will say? Y minus 0 upon 2, Y minus X upon 4, Y minus 100 upon 6 equal to 0. Okay. Now with the equation you calculate the value of the X, you calculate the value of the Y. The net resistance of the circuit can be written as 100 upon I. I you can easily calculate. I is written as I1 plus I2. Let me explain here. 100 I. What I can say? In this branch current is I1, in this branch current is I2. So what I can say? X upon 3 plus X upon 2. Y upon 2. Now you solve yourself. Okay. Now I will discuss the symmetry situation. In this situation you are observing at the A point there are two resistance 5 and 10. Here again two resistance 10 and 5. So definitely there should be some symmetry in the current distribution. Again suppose I assume there is a battery of 100 volt is connected. Here you will say at this point voltage is 100, at this point voltage is 0. Okay. Now it is symmetrical situation. In this 5 ohm and in this 5 ohm same current should flow. Suppose I say here the current is I1, here also current should be I1. Similarly in this 10 ohm, current should be same, because at this junction same resistance are there, here also same resistance. I assume here the voltage is X. Now across this 5 ohm potential difference is 5, I will say X minus 0 is X volt. It means same X volt should be potential difference across this 5 ohm. It means what I can say, this should be 100 minus X. Now you can visualize 100 minus 100 plus X. You will say X volt here. What is potential difference across this 10 ohm? You will say 100 minus X. What is potential across this 10 ohm? 100 minus X minus 0 is 100 minus X. Now it is clear. Now we will write KCL equation for node X. And what we will say? Observe it. This is X minus 0 upon 5. I can write X minus 0 upon 5 plus X minus 100 minus X upon 10 plus x minus 100 upon 10 equal to 0. Now you will solve yourself. You will get the value of the x, that is 40 volt. Now I require the equivalent resistance. Let me write here R equivalent net voltage upon net current in the circuit 100. I is equal to I1 plus I2. For I1 what is voltage difference? X upon 5. For I2 what is 100 minus x upon 10. You put the value of the x, you please calculate yourself. Finally you will get the result that I am writing here, that is 50/7 ohm. Now I will discuss the branch manipulation in some circuits. This is a series circuit. You observe the first diagram. In series, we can manipulate the branch as per our wish. You can shift the cell here, you can shift the resistance here, you can add it, and you can finally write it to simplify the solution. So 5 and 3 8, and that is 10. If one more battery is there, we can see that is same polarity, opposite polarity. According to that, we can convert this branch into single resistance and single cell. Okay. Now, all of you calculate electric resistance across A and B. First you pause the video, apply your brain and solve it.